Hello guys. Today we're going to look at lesson 7-2 for solving systems of equations. When we started this chapter, I told you that there were three different ways to solve systems of equations. In the last lesson, we learned how to solve systems of equations by graphing the system. And again, the solution to the system when we use the graphing technique is where the two lines intersect. So whatever point that the lines intersected in the coordinate plane, that was the solution. But that's not always the most effective method for solving a system of equations, especially when the solution does not contain integers. So it would be really tough to read the graph to determine exactly where those two lines intersected. So the second method that we're going to look at is called solving systems of equations by substitution method. But before we get started here, let's solve a couple of equations, very basic equations, because again, it is so important that we keep this skill sharp. We have to be able to solve equations well. So let's look at the first ones here. All right, we have m minus 6 equals 4m plus 8. So as we can see here, we need to get our m's on the same side. So I'm going to subtract m from the left side and move it to the right side. So 4m minus 1m is 3m. And then we're going to get our constants on the other side. So since we have an 8 that is added to our m's, we're going to subtract 8. So negative 6 minus 8 leaves us with a negative 14. Now to isolate our m, we have to get rid of this 3 because the leading coefficient has to be a 1. So we're going to divide both sides by 3. So negative 14 divided by 3, and we are finished. Let's look at the second one here. This one involves a fraction. You guys love fractions, but we work them the same way as we do integers. So we have to isolate our variable. So to isolate our variable, the first thing we have to do is subtract 5 from both sides. So 10 minus 5 leaves us with 5. Now our leading coefficient here is a fraction. Now this fraction is multiplied to the variable, so we would say that we would divide to get rid of it. But since it's a fraction, in that division process, we end up multiplying by the reciprocal. So what is the reciprocal of 1/3? Well, it is 3. So if we multiply both sides by 3, 5 times 3 is 15, and we are finished. So again, a couple of basic equations to keep our skills sharp for solving equations, because we're going to have to do it in this lesson. All right, let's get rid of some vocabulary. When we use the substitution method for solving systems of equations, it is very, very simple. Substitution means to replace. And we only replace when things are equal in value, and we're going to see that in our examples. So the substitution method is when you replace one variable with an equivalent expression. So for example, if I say that y equals 2x minus 7, and I also tell you that y equals 3x plus 4. Since both of these are y equals, that means that 2x minus 7 and 3x plus 4, even though they look different, they are equal. And the reason we know that they are equal is because they are both equal to y, and of course y is equal to y. So even though 2x minus 7 looks different than 3x plus 4, they are equal. And remember, anytime things are equal, we can set them equal to one another. So since the expressions are equal, we're going to set them equal to each other, and then we're going to solve for x. Okay, so let's look at an example. Now, we can be given a system of equations in several different forms. If you recall from the last lesson and the last chapter, equations of lines can be written in slope-intercept form, they can be written in standard form, and they can also be written in point-slope form. And those are just the common forms. We could actually have an equation of a line that's really not written in any form. But the easiest way to solve a system of equations using substitution method is when your equations are both written in slope-intercept form. And our first example here has our system where our equations are written in that form, y equals mx plus b. So here we go. So just like in the definition on the previous slide, we have y equals 2x plus 2, and we have y equals negative 3x plus 4. This is your system. So we're not graphing in this lesson. That was the last lesson. This time we're substituting. So since both of these equations are y equals, we can take the expression parts and set them equal to one another. So we take y equals 2x plus 2, and we take out the y. Now, we're going to take out this y right here, and we're going to replace it with what y is. Well, y is also equal to negative 3x plus 4. So we took the y out and we put in its place negative 3x plus 4. And now, just like our warm-up problems, we're going to solve for x. So let's get our x's on one side. So we added 3x to both sides. So 2x plus 3x gives us 5x. And then we have to isolate our variables, so we have to get rid of this 2. So we're going to subtract 2 from both sides. So 4 minus 2 is 2. One last thing to do is to isolate the variable, make its coefficient 1, so we have to divide both sides by 5, and 2 divided by 5 leaves us with 2/5 or 0.4. Now, this is a terminating decimal 0.4, so it's allowed. If our fraction would have been a non-terminating or repeating decimal, you would have had to have left it in simplified fraction form. All right, so we know the x value. We have half of our answer because remember, the solution to a system is always an ordered pair. So we now have the first coordinate of our answer. We have the x. Now notice this is step 1. There are 2 steps when you solve a system of equations by substitution. So step 1, you set the expressions equal to each other, and then you solve for x. Now, step 2, we're going to take this value, we're going to take this x value, 0.4, and we're going to substitute it back into one of these 2 equations. And it does not matter which one you pick because they're both y equals. So I always look for the one that has the smallest numbers, values that are positive, and I try to avoid fractions if I can. So let's take y equals 2x plus 2. So we're going to take this first one right here, y equals 2x plus 2, and we're going to take this x out, and we're going to replace it with what x is. We already found x. X is 0.4. So here we go. We took the equation, we took the x out, and we substituted in a 0.4. Now just follow the order of operations. 2 times 0.4 is 0.8, and 0.8 plus 2 is 2.8. We just found the y-coordinate, which was the second half of our answer. So we believe right now that the answer is 0.4, which is the x-coordinate, and 2.8, which is the y-coordinate. But just like in lesson 1, we have to check our solutions to make sure that it does work, and it has to check in both equations. Now, we only have to check it in one equation here, because let's go back for a second. You can see here that we use the equation y equals 2x plus 2 to get our answer for the y value. So we know that it checks in this first equation, y equals 2x plus 2. So we only have to check it in the one that we didn't use yet, which is the y equals negative 3x plus 4. So let's substitute it into y equals negative 3x plus 4. And if it checks true, then we know that 0.4 2.8 is a solution to the entire system. So here we go. So we're going to take the y out. Remember, we're putting it into y equals negative 3x plus 4. So we're going to take this y out and put in what y is. Y is 2.8. Then we're going to take the x out and we're going to replace it with 0.4 because that's what the value of x is. So 2.8 equals negative 3 times 0.4 plus 4. Now notice this question mark at the top, because we're checking to see if it's true. We don't yet know if it's true, so that's why there's a question mark there. We're not sure. So let's follow the order of operations. Negative 3 times 0.4 gives us negative 1.2, and negative 1.2 plus 4 leaves us with 2.8. So is the right side of this equation equal to the left side? And we can see that it is. These values are the same, so we know that it's true. So therefore, this solution, 0.4, 2.8, is a solution to this system. All right, let's look at a second example here. It says solving using substitution again. That's all we're going to be doing in this lesson. We have a system of equations, but if we examine this system of equations, we can see that either one or more of our equations are not written in slope-intercept form, meaning y equals mx plus b. So our first step is to get them written in that form. All right, so let's take the first equation. We have negative 2x plus y equals negative 1. And to get it into slope-intercept form, we have to move the negative 2x to the other side, so we're going to add 2x. So we have y equals 2x minus 1. This equation is now in slope-intercept form. Now let's take the second equation because we have to get it into slope-intercept form as well. So, well, here, this example here, they didn't isolate the y in this one and do it like we did example 1 where you could set the expressions together. They went ahead and took what y is equal to, which is 2x minus 1. They took this y out right here and they substituted 2x minus 1 in its place. So that's an option too. So let's go ahead and go with that since this is the way these notes do that. So we have to follow the order of operations now. We have to distribute the 2. 2 times 2x is 4x, and 2 times negative 1 is negative 2. Combine your like terms. 4x plus 4x is 8x. And we moved the negative 2 to the right side. We had to add 2 to both sides, so 12 plus 2 is 14. Then to get x by itself, we have to divide both sides by 8. 14 divided by 8 leaves us with 1.75. Now, 1.75 is a terminating decimal, so we're allowed to leave it like this. If 14 divided by 8 would not have been a terminating decimal, you would have had to leave it as a simplified fraction. All right, step 3, we have to solve for y in the other equation. So when we go back here, you can see that all we've done so far is solve for the x. We only have half of the answer. We have to find the second half of the answer by solving for y. Now you notice it said step 3, you have to put it into the other equation. What they mean by other is you can't use the same equation that you just used to find x. So if we used 4x plus 2y equals 12 to find x, we can't use that equation to find y. So we have to come back up to our system, and we have to use this equation right here. So we're going to take negative 2x plus y equals negative 1, and we're going to substitute what we found for x in for x. So we're going to take this x out. We're going to put in 1.75. So let's do that, and then follow the order of operations. So we have negative 2 times 1.75. That leaves us with negative 3.5. And then we have to get y by itself, so we're going to move this negative 3.5 to the other side. Since it's negative, we'll add. And negative 1 plus 3.5 leaves us with 2.5. We have now found the y-coordinate of our solution. So we believe that the answer is 1.75, 2.5. But we have to check. Now, we just used this first equation, negative 2x plus y equals 1, to find y, so we now have to check it in the other equation. So you kind of bounce back and forth between the equations. Okay? Alrighty. Let's try one on our own now. That's all we're going to be doing today is solving systems of equations by substitution method. So solve by substitution method. Now to give you a hint before you get started on your own, and I'll have you pause this video in a moment, look at your system. Analyze your equations. Ask yourself, what form are my equations in? Are they both in slope-intercept form? Are they both in standard form? Do I have one in slope-intercept form and one in standard form? You have to analyze your system to see what is given so that you can decide how you're going to move forward with this problem. Now we can see here that both of our equations is like our first example that we did in this video. They are both in slope-intercept form. So when they're both in slope-intercept form, what do you do to solve the system? So pause this video for a second, go to your notes or on a sheet of paper, solve this system, use your notes. I sent you guys a copy of the notes for lesson 7-2. Use your notes, and then come back and resume the video to see if you got this correct. So pause now. All right, guys, welcome back. All right, we have our system that is where we have equations that are both in slope-intercept form. So all we have to do is take the expression parts right here, 2x, and 7x minus 15. Since they're both equal to y, that means these two are also equal. So all we have to do is set them equal to one another. So we take the 2x, set it equal to 7x minus 15, and get our x's on one side. So I'm going to, well, the first thing we did was move it around, and we have 15. We added it to both sides, so it gives us 15 plus 2x, and then we subtracted 2x from both sides. 7x minus 2x leaves us with 5x, and then to get x by itself, we have to divide both sides by 5. 15 divided by 5 is 3. So we have half of our answer. The x-coordinate is 3. Now, since we used both equations in this method where we set them equal to each other, it doesn't matter which one of these two we use to find our second part of our answer. Pick the easiest one. That's what I like to do. So I'm going to pick that first equation. We have y equals 2x. We're going to substitute in what we just found for x. X is equal to 3. So in place of x, we're going to put a 3 in. 2 times 3 is 6. So the solution to this system is 3, 6. Now, we used this the first equation to find our y-coordinate. So when we go to check our answer, we would have to go back and check it in this second equation. Substitute 3, 6 into your second equation. Does it check to be true? Make sure you check. You'll put a 6 in here, you'll put a 3 in here, and simplify. Both sides should come out to be equal. So 7 times 3 is 21. 21 minus 15 leaves us with 6. So we will get 6 equals 6. So we know that 3, 6 is the solution to this system.